These are your notes for Unit 5, Day 5 of Algebra 1. If you would like to see your warm-up, review question, or any homework questions we went over in class, just look at the finished notes. So today is the last day of our Systems of Equations unit, and today we're going to look at systems of linear inequalities. So we graphed these in our last unit. So these are the ones where you would graph the line and then decide if it was dashed or solid based on the inequality sign, and then would you shade above the line or below the line. Well, today we're going to do the same thing, but we're going to have systems of them. So we'll have more than one shaded area, and the answer will be where the shaded regions overlap. And then we'll talk about how we can use these ideas to look at to model a given problem. So here is a system of linear inequalities. So we have x plus 3y is less than or equal to 6, and 2x is greater than y. So your steps for these, your first step is you want to solve for y so you can graph them, because you want to be able to graph y equals mx plus b. So let's look at that first one. X plus 3y is less than or equal to 6. So we're going to get the y by itself, so we're going to subtract x from both sides. And we have 3y is less than or equal to negative x plus 6. And then we divide every term by the 3, so y is alone. So we have y is less than or equal to negative 1 over 3x plus 2. That's like a negative 1 over 3x. So for this one, we're going to start at 2 because that's our y-intercept, and then we'll go down 1 and then to the right 3. And then if you remember from last unit, if it is less than or greater than, then we're going to have a dashed line. And if it's less than or equal to or greater than or equal to, we will have a solid line. So notice in our first equation, we have y is less than or equal to negative 1/3 x. So it's going to be a solid line through those points. And then we are saying that the y values are less than the line. So if this is a y value right here of 2, we want the y where the y values are less. The y values are less as we go down. So I'm going to shade below that pink line. So that's going to represent all of the solutions to that first equation. Now we're going to look at that second equation. 2x is greater than y. Well, I'm going to flip that. So it's going to be y is going to be less than 2x, and then it needs a y-intercept, so we'll do plus 0. So y is less than 2x plus 0. So this line is going to start at 0, and then we're going to go up 2 and over 1. And so those two green points will be on our line. And then notice it's just y is less than. So this time it's going to be a dashed line. And then notice y is still less than that. So I need to shade where my values are less than that green line. So where are they less than that green line? Well, here's a y value. To be less than, I need to shade underneath. So I need to shade all of the values underneath. So I'm going to shade underneath that line. And then my solution is going to be where all of the shading overlaps. So where does the pink and the blue overlap? Well, it overlaps down in this region right here. So if you're using your iPad at this point, you can erase all of the shading that doesn't work. So I'm going to erase that shading, and I'm going to erase that shading. So all of my shading exists down in that lower right-hand quadrant. So any point in that shaded region would be a solution to the equation. So let's look at another one. We have negative 3x plus 4y is less than 8. X is greater than 1, and y is less than or equal to 5. Well, let's do these ones first. So if I wanted to graph x is greater than 1, let's start with the line itself. What does the line x equals 1 look like? Well, it's the line where x is always equal to 1, so it's going to be a vertical line. And it's just greater than, so it's going to be a dotted line when x is equal to 1. And now we want the values where x is greater than 1. Well, where are the x values more than 1? Well, when they're 2, 3, 4. So I'm going to shade to the right of that dotted line. So all of my solutions for that second inequality, x is greater than 1, would exist there. Now let's look at y is less than or equal to 5. So first we want to graph the line. That's where y is equal to 5. So 1, 2, 3, 4, 5. It's the line where y is always equal to 5, and it's less than or equal to, so it's going to be a solid line this time. And I want all the y values that are smaller than that line. So that would be underneath. So I'm going to shade here. And again, my solution's only going to be where the shading overlaps. So right now, the shading overlaps in that bottom right area again. So I'm just going to shade down here. So that's where my shading overlaps. And then I'll erase here. So my green and my pink overlap down in this area. But I'm not done yet. I still need to do my top line. So for my top line, I have to solve for y. So 3x plus 4y is less than 8. To solve for y, I'm going to add 3x to both sides. And I have 4y is less than 3x plus 8. Then I'll divide every term by 4. So y is going to be less than 3/4 x plus 2. So this line will start at 2, and then it'll go up 3 and over 4. 1, 2, 3, 4. And it's just less than that line, so it's going to be a dotted line, and then I'm going to shade below that line. So I'm going to shade everywhere below that blue line. And then again, I want where all of the shading overlaps, so I'm going to erase this area, and I'm going to erase up there. And then where the pink and the blue and the green overlap are going to be in this area right here. So any solution, any point in that shaded region would work because it's less than the blue line, to the right of the green line, and below the pink line. So that would be my shaded area that would work for all three linear inequalities. All right, let's look at another one. Y is less than 1 over negative 2x plus 4. So if I were to graph this, I'm going to graph the line y equals negative 1/2 x plus 4. So it's going to start at 4, 1, 2, 3, 4 on the y-axis, and then we're going to go down 1 over 2, or you could go up 1 and to the left 2 if you wanted to. And it's just less than, so it's going to be a dotted line. And then we're going to shade below that line. So this is going to be my solution for that first line. For the second line, we have y is greater than or equal to x minus 1, so we'll start at negative 1. And then we're going to go up 2 over 1. And this time it's a solid line because it's greater than or equal to. And where are the y values greater than that line? They're greater than above the line. So I'm going to shade above that line. And I only want the solutions where the pink and the blue overlap at this point. So I can erase this blue right here. And I can erase that pink right there. So that's where my shading overlaps, is over in that left area. And then one more, we want where x is less than 5. So 1, 2, 3, 4, 5. Here's where x is equal to 5, and it's going to be a dotted line because it's just less than 5. And then I want all of the values of x that are less than that, so I'm going to shade to the left. So I'm going to shade everywhere over here. But again, for these, I just want where the shading overlaps. So I'm going to erase up here. And I just want the areas where the green, the pink, and the blue overlap, which would be in here. So any point in that region would be a solution to the system of inequalities. All right, so how can we apply this to a real-world problem? A college student is deciding how many hours to work at a part-time job, so the number of hours is going to be X, and how many hours to work at an internship, so the number of hours for the internship are Y. The job pays $24 an hour, and the internship pays $12 an hour. The student needs to work less than 15 hours a week, but needs to earn at least $240 a week to pay expenses. So we're going to set up a system of equations like we did in our last class, but this time instead of equations, they're going to be inequalities. So we have X is the number of hours at her job, and Y is going to be the number of hours at her internship. And I know that she needs to work less than 15 hours. So if I take X plus Y, those are the number of hours, they need to be less than 15. So when I add up all of her hours, it needs to be less than 15 because she needs to study and go to class. But she also needs to make at least $240 an hour to pay for her expenses. Well, she earns 24 hours at her job, so 24 times X is how much money she'll make at her job every week. Plus, she makes $12 at her internship, so $12 times Y is going to be the amount of money that she makes at her internship, and we need that to be greater than or equal to 240 based on the problem. So that's going to be my system of inequalities. Now we're going to graph them, and then we're going to talk about what that solution means. So if I take x plus y, it needs to be less than 15. So we're going to graph it just like we did before. So we're going to solve for y. So y is going to be less than negative x plus 15. So y is going to be less than negative 1 over 1x plus 15. So this line's going to start at 15, and then it's going to go down 1 over 1. And it's a dotted line, so we're just going to make it a dotted line, down 1 over 1. And then it needs to be less than that, so I'm going to shade below the line. So all of the solutions in that area represent the number of hours she could work at each job. Now let's do the other one. 24x plus 12y is greater than or equal to 240. So subtract the 24x, subtract the 24x. And 12y is greater than or equal to negative 24x plus 240. Divide by 12, divide by 12, divide by 12. And then y is going to be greater than or equal to negative 2x plus 20. So this one is going to start at 20. And then it's going to go down 2 over 1. And it is going to be a solid line. So we're just going to go and make it a solid line. And then we want all of the values greater than that. So greater than that means that I would shade, oops, I'm going to the highlighter. We're going to shade all of the y values more than that. So we're going to shade above the line. And these values are above the line. But again, I just want where the two pieces overlap. So I'm going to erase all the pink where they don't overlap. And the only place where the green and the pink overlap are going to be in this little area right here. So then I'm going to erase the rest of the green. And so the only area that I want is in that little triangle right there. So what does the shaded area represent? The shaded area represents all the hours. So this is X. So these are the hours at the job. And then here are the hours at her internship. This represents the number of hours she could work at the job, at her job, and the number of hours she could work at her internship, so that she works less than 15 hours but makes at least $240. So for instance, this point right here would represent the point 10 for X and 1 for Y. So she could work 10 hours at her job and 1 hour at her internship, and she would make at least $240, and she'd be working less than 15 hours that week. So all of the solutions in that shaded green pink area represents the number of hours that she could work at her job and her internship, so that the number of hours is less than 15, but she makes at least $240. So can the student work $5 at her job and $5 hours at the job and 10 hours at the internship? So 5 hours at her job would be right here, and then 10 hours at the internship would be right here. So could that work? Well, no, because she has to work less than 15 hours, and if she did 5 hours and 10 hours, that would be equal to 15 hours, and she would like to work less than 15 hours. So no, that wouldn't work. All right, so your test is coming up. Ways to study. As a reminder, you want to look over your notes. You want to look over the finished notes that are posted in the modules. You want to look at the video notes that are also posted in the modules if you need to. You want to look over all of your exit tickets and homework. And then you want to complete any review activities and assignments. So you will have bookworks. You'll have a review problem set from the book. You will have a review problem set on Socrative, and then there might be other things to review. So complete any review assignments. So from the book and from Socrative. And then make sure you review for your spiral section as well. So here is the bookwork. If you have any questions, let me know.